Yeah. Oh, you're fine. All right, well, I will get started. I see I'm starting a little bit late, so I'll make sure to go a little bit late, just to be fair. I threatened there would be homework, but I have not assigned the homework yet. Um, so I have oh, sometime soon. They should be posted like today if you remind me. If I don't do it today, like email me. I said if I don't do it today, email me. But I intend to do it today. I think. All right. In fact, I thought well, anyway. So these are from section 4.5. Let me start with number 42. Here we're asked to solve 3 to the 4x minus 3 to the 2x minus 6 equal to 0. All right, so just to let you know where we're going, we're going to be solving a bunch of equations from section 4.5 today. And then if there's still time, we'll start talking about the old tests at the end, all right? So what should I do here? I mean, generally speaking, if you have an exponential equation, if you can isolate the exponential, that's a way to solve it, right? But the annoying thing about this one is, like, if I try to isolate the 3 to the 4x, then the 3 to the 2x is still, like, over there with something added. If I try to isolate the 3 to the 2x, I still get, like, 3 to the 4x plus something or minus something. I can't isolate either one of these. It's kind of annoying. So what you can do in this kind of situation is make a substitution. So we'll let y equals to 3 to the 2x, I think we'll do it. Then y squared is 3 to the 2x raised to the second power, which by the laws of exponents is 3 to the 4x. So with this substitution, the original equation becomes y squared minus y minus 6 equal to 0. And I think that one we can factor, right? This is y minus 3 times y plus 2 equal to 0. And what's that give us? Yeah, negative 2 and 3. So y equals to 3 or y equals to minus 2. But we're not done, right? Because we're trying to solve the original equation, right? So we need to try to track back and see what that says about x. So this one says that 3 to the 2x is equal to 3. And this one says that 3 to the 2x is equal to minus 2. All right? Now, probably the easiest way to solve this one is use the one-to-one property of the exponential. So like one-to-one property of the exponential says if you've got 3 to the 2x equals 3 to the 1, this tells us that 2x is equal to 1. Or if you like, you could take the log base 3 of both sides and get that as well. All right, but 2x equals to 1, so x equal to 1/2, right? And this, on the other hand, is impossible. Right? You can't have an exponential give a negative value. Right? At least not a real exponential. So that's number 42. X equals 1/2 is the only solution here, yep. Let's see here. Let's see if we can work number 47. So number 47, we've got 4x cubed e to the minus 3x minus 3x to the fourth e to the minus 3x equals 0. So any advice you guys got for me about this problem? Not in life general. E to the minus 3x cancels. Sure, so we could basically multiply by e to the 3x, right, to cancel e to the minus 3x. So we've got like 4x cubed minus 3x to the fourth equal to 0. Right. I guess you know what, I need to put another step in there because I just got done grading a 101 test, and I mean was it 101? Yeah, 101. And goodness gracious. It's probably important for me to show steps. So the point is I can factor out e to the minus 3x, right? Like it's important that it's on both terms so I can factor it out because that's what allows me to make the cancellation that Jared was just encouraging me to do. So like divide by e to the minus 3x or multiply by e to the 3x, and this implies that 4x cubed minus 3x to the fourth equals to 0. One way to argue this is because e to the minus 3x is not equal to 0, right? If e to the minus 3x is not equal to 0, that implies that whatever's multiplying it must be the thing which gives us 0, right? So how do we solve that? I'll do the easy part. I'm going to pull out an x cubed. And that's going to give me 4 minus 3x, right? So then what? Very good. Yep. So this one has two solutions. It's either that or that. And I mean, it's always good practice to check your answer here, but there in some sense is no need because I never made a step in our calculations which is not reversible, right? Like that step of, because e to the minus 3x is not equal to 0, it's not like it's usually not equal to 0, or for some x it's not equal to 0. It's just categorically true that e to the minus 3x is non-zero. So, okay, let's move on here.
Where did the 4 go again? So you have 4x to the third minus 3x to the fourth?
Well, I factored out x cubed. So like 1 from here, and then also 1 from here. So that's, x to the fourth is x cubed times x, which leaves me an x here. Okay. Yeah. Let's see here. Let's work. So now we're moving on. There's about, I would say there's about 5 or 6 different sort of distinct problem types in this section, right? So that's why it's taking me a while to get through them all. They're all based on applying laws of logarithms and laws of exponents, right? It's all always anchored on those facts that we began with. Let's see here. I'll start with number 49. 49 says log of x plus log of x minus 1 equals log of 4x. And so this is the common log, right? This is log base 10. So how should we handle this? I think what I'm going to do is I'm going to combine the two logs on the left-hand side, right? And then I can use the one-to-one property of log to go from there. what I'm saying is these two simplify into log of x times x minus 1. And of course, that's equal to the log of 4x, right? What's that? Yeah, you could do that. Sure. We'll have to do it in the next step, but yeah. It will matter at some point. So at that point, we've got log of something equals log of something else. And so by the one-to-one property of the logarithm, it follows that those arguments have to be equal. If you don't like that, you could take both sides and raise it to the, like, exponentiate base 10, right? Like 10 to this log equals 10 to that log, but the 10 to the log power cancels, and we're just left with x times x minus 1 equal to 4x. Now at this point, I'll do what Jared said, x squared minus x minus 4x equals to 0, which of course is x squared minus 5x equals to 0, which is x times x minus 5 equal to 0. Yeah, so x equals to 0, and x equals to 5. Now, x equal to 0. This is troublesome, because can we take the log of 0? The answer is no. So the input to a logarithm must be positive. Log of 0 is not defined. So this is an extraneous solution. It is the, basically, see here. I mean, it's been with us from the start of this problem, I suppose. Yeah, I guess it's not really something that, I'm trying to think of how to explain where that came from. I think it's just with the problem to start with. I'm not sure that there's really a step I did which introduced 0 this time. Anyway, it's not so important for me to explain. The important thing is that when you do a problem like this, you need to check your answers to rule out the extraneous solutions, right? X equal to 5, on the other hand, is okay because log of 5 is okay, and log of 5 minus 1 is log of 4, that's okay. Log of 5 times log of 5 plus log of 4 is the log of 20. And of course, on the right-hand side, we have log of 4 times 5, which is log of 20, so log 20 equals log 20. So it checks. There you go. Let us do another. How about 52? Well, I'll do 53. 52 is kind of more or less the same problem we just worked. 53 looks a little bit different. Log base 2 of 3 plus log base 2 of x equals to log base 2 of 5 plus the log base 2 of x minus 2. So how should we how should we proceed? Did you already do it? Combine the left-hand side and combine the right-hand side. So you use property of logs on both sides? Yeah. Okay, I'll buy it. So this is log base 2 of what? And that's equal to log base 2 of what?
3x and then 5x minus 10.
So 5x minus 10, okay. So you multiply through the 5, obviously. And then we can, right, yeah, those, essentially the log base 2's cancel, or you could think of it this way, 2 to the log base 2 is equal to 2 to the log base 2 is inverse functions, they cancel out, just leaves us 3 to the x equals 5x minus 10, which of course gives us 10 equals to 2x, also known as 5 equals to x. And then you can go back and check that that works, right? If I plug 5 back into the original equation, I get log base 2 of 3 plus log base 2 of 5. On the other side, I get log base 2 of 5 plus log base 2 of 5 minus 2, which is 3. So, yay. You guys are like, these are boring. Put these on final exam part 1. I'm ready for it. I've seen enough, right? You guys are immune to my comedy. You're not even reacting to it anymore. What's that?
Harder ones?
Are there harder? Oh, yeah, there's harder ones. Sure. Let me ignore the textbook for a second. So, what if we tried to solve like natural log of x plus log of x equals to 7? How would we do that? Very carefully. How would we solve such a thing? Or, while we're at it, how would you solve something like 3 to the x plus 7 to the x equals to 8?
Where you do like log x to the 3 or something like that? Or is it ln?
Well,
No, there's like something.
I mean, this one,
There's a way.
Somewhere in his brain.
I don't know. I mean, just because I can write an equation down doesn't mean we can solve it. I mean, this doesn't help, right?
So you don't know if these are solvable.
No.
So how am I going to figure it out? Or anyone here?
You guys are smarter than me. You'll figure it out.
Yeah.
You're still young. Your brains are malleable. You have all kinds of creativity. Not solvable is actually like a technical term. Actually, the term simple in mathematics has at least a half a dozen different like technical definitions. Now this one, I'm actually kind of scared. I'm actually kind of scared of the problem I just wrote down. I'm not sure I can do that one.
Top one or bottom one?
I think the top one can be done, but you got to have. Well, I'm not sure. Let me show you how I'd attempt it. So, what you're thinking of, and Jared was not far off base. He's saying I need to change the base. He just didn't remember the words for it. And so, like this is log of x plus the natural log of x divided by the natural log of 10. Because remember, common log is log base 10, right? And the change of base formula is that log base b of x is log base a of x over log base a of b. So in the special case of natural log, that just becomes, natural log of x over natural log of b. But in this case, the b is 10 because it's common log. So this is just that. Oh, and here? Oh, I'm sorry. Log base b of x equals to log base a of x divided by log base a of b. Yeah, it's hard to choose a font size which is big enough for all these things to come up on the board. So by the change of base formula, I can do this, and it's equal to 7. So, and then I've got 1 plus the natural log of 1 plus 1 over natural log of 10 times the natural log of x equals to 7. And so, natural log of x is equal to 7 divided by 1 plus 1 over log 10, which means that x is equal to the exponential of 7 over 1 plus 1 over log 10. And so there you go. That one's not impossible. There you go.
It's on the test, I'm just gonna get a 0 on it. That's okay.
It was your idea to change the base.
I didn't even know what I was talking about. I was talking about the bottom example. Not
And
the top one.
oh, the bottom example. Yeah, that one's
All I was on this.
that one scares me.
Test 1 through 3 are only exam next
Reel
week.
it back into like the left and right side.
Yeah, test. Final exam part 1 will cover test 1, 2, and 3. It's not this nonsense.
Okay. So is this going to be on the second one?
Final exam part 2, and also the remaining homework that I have not yet published, and I will not publish until the final
But
exam
like
is.
a problem like that hard.
So like the Monday and Wednesday of next week are final exam part 1. Then Friday I will reserve to talk about your last homework with you in person.
So, have you already posted our last homework right now?
No, I have not. In fact, I'm not going to until the final exam part 1 is done, just so I don't distract people with it.
Okay, so
Yeah,
the final exam part 1 is Monday.
Monday and Wednesday,
Monday and Wednesday.
2 parts. Yeah.
I have a question. How did you get rid of the natural log on the left side, the second step is on? Like, natural log just went to A.
Oh, I took e to both sides. So like this is e to that, is e to this. But since e to that I don't like to write, I instead wrote it as exponential, like exponential of the natural log of stuff equals stuff, provided that the stuff is positive. You know? I still do need to send an announcement out about like what's still remaining to do in the course. So I mean, I'm going to send an announcement which says what I just told you and a little bit more just about like what's on final exam part 1 versus what's not and what to expect.
Why did the ln x over ln 10 change to 1 plus 1 over ln of 10?
Let me get rid of the e here for a second. So you're asking about this equation?
No, back 1, yes.
Oh, I just factored out, this is 1 over log 10 times ln of x over, like ln of x over natural log of 10 is equal to 1 over log 10 times the natural log of x. So that's just a number. So this is like 1 times natural log of x plus 1 over log 10 times natural log of x. I just factored log x out.
Okay.
It's just plain old factoring, going from here to here. I factored it out right here. I mean, if I listen, if you multiply this right here out, we get back 1 times log x, which is log x, and then log x over log 10, which is right here. Those are the 2 terms which I have rewritten in that way, going from here to there.
Okay.
Yeah. Now, the other problem, it does scare me. I'm going to try it. And thank you, Jared, for asking me to work problems outside the book. It's really made today much more interesting for me. I really appreciate that you asked for that. It was very kind. One of the highlights of my week, really. Let's see here.
Well, I'm glad I made your week. Right now everyone's hating on me right now.
Yeah. So in order to solve this, like my strategy would be to try to convert them all to like objects of the same type. So if they're all like 3 to the x, I have a hope of kind of making a substitution and doing it. Maybe. So how can I convert 7x to 3 to the x? I can do 3 to the log base 3 of 7 to the x. That's an identity that I can use to convert 7 to the x to 3 to the x, 3 to something, not x anymore. But what I have is 3 to the x plus 3 to the x times log base 3 of 7. And it's still not nice. Because, well, let me just make a substitution, show you why it's not nice. If we let y equal 3 to the x, then what we're facing here is y plus y to the what? Y to the log base 3 of 7 equals to 2. Or, do you remember when we learned how to solve equations like this? Like log base 3 of 7 is some number. It's you know, 1.8 or something, you know? This is something like y plus y to the 1.8 power equals to 2. How do you solve such a thing? The answer is with technology, right? So like this problem probably only permits a numerical solution. So this problem is very different than my first example. Like this one we can work, we did. But this one, even though it's kind of like the same idea as that, it just doesn't work out nice, right? So in short, the only way I could ask that is if I also was allowing you to use technology to like find approximate solutions. I would use a graphical approach. I would like graph 3 to the x plus 7 to the x, and I would graph 2, and I would look for the intersection of the line y equals 2 and the 3 to the x plus 7 to the x graph. Where those intersected, that would be my solution. Certainly a solution exists. But, oh, well, actually, does a solution? I'm pretty sure a solution exists. Because as x goes to like minus infinity, these get super tiny. So these go to 0 for x really negative, and they're definitely larger than 2 for x really positive. So there's got to be some place where this formula crosses 2, and it's continuous, so it's got to cross somewhere. Hey, I know how to make that problem workable. What? You don't care? What if instead of, I bet if we did 3 to the x times 7 to the x equals to 2, maybe we could solve that. What's 3 to the x times 7 to the x? Can we simplify that using laws of exponents? So what is 3 to the x times 7 to the x? Can we? Well, I'm not. I mean, if you're not, I'm not hearing any. I'm not hearing any answers. So let's take the natural log of the equation.
Is it 21 2x? Is that what it would be?
I think it's 21 to the x.
For which one? Left or right?
The left-hand side. And so like this is log 3 to the x plus log 7 to the x. So if you don't have confidence about it being 21 to the x, then here's how you could go anyway. This is x log 3 plus x log 7 equals log 2. And so that's x times log 3 plus log 7 equals log 2. What is log 3 plus log 7? It's log of 21. So x is equal to the log of 2 divided by the natural log of 21. That's how I would get to it if I didn't have the insight to say what. So if I didn't have the insight to do what Mary told me to do, like a minute ago, but I. Right, I mean, this is like way easier if we just make this step. 21 to the x equals to 2, right? And so that takes the natural log of both sides, we get, And can you guys tell me like another way to write the answer? What's this equal to? Log base what of 2? Log base, I mean, as it stands, it's log base e of 2 divided by log base e of 21. That's what that is, literally. That's just a different notation. Can you fill the blank here that this is just log blank what of 2? So you guys need to study the change of base formula more. Means I should put change of base formula problems on your homework. Yes, I should. Log base b of x is like log base a of x over log base a of b. So in this context, if we think about, this is the
Is it log base 21?
log base 21. Okay. Sorry I'm so late for class today. I was grading this test earlier in office hours, and it was just fascinatingly wrong. It didn't have one wrong thing. It had like many wrong things, and yet the logic of the wrongness was still clear. It was magnificent. Like something like this. Let's see if I can remember it. This was like the problem. It starts like this, and then they do this. It's like, you can't just multiply the denominator, right? But the reason they did that was so that they could cancel the 2's. Oh, but it gets better. Next step. Answer. 1.
My bad.
That's pretty good. That's pretty funny.
What makes it funnier is the instructions to the problem.
I think you should give him points for that.
This is f of x. The instructions are find domain of f of x and express in interval notation. I guess that could be a question on your test, right?
I mean,
So like
the answer is
101.
1 to.
I was like, what? Just, God, so much wrongness. And yet I could understand the wrongness, but at the same time I was fascinated by it. The answer here, minus infinity to 6. 6 to infinity. You got it, okay, good. But I mean, that's the domain, because when you look at this formula, we just have to avoid x equals to 6. X equals 6 gives me division by 0. That's what we don't want,
I hope that person goes back and watches this video.
I
I mean, they're not.
I don't think they'll watch it, but
I would.
Yeah, I think he's pretty confident in
He
that
will.
answer.
When he does, he's gonna see this. Go do video. What's today?
yeah, the 13 over 12 equals it's because it's 13 minus 12, right? That's what that notation means.
Yeah.
I mean, and the thing is, I can't fix it. I can't fix it. I tried to fix it.
What you on his paper?
Oh, a few different things. All right, number 55. Number 55, number 62. And let's see here. Number 78. Log base 2. Oh, here's like a kinder, gentler version of the problem I made up for Jared. Log base 3 of x. I mean, it is, but it isn't. I mean, oh, and there's still inequalities. Oh, man. Those are in Skills Plus. Maybe Anyway, let's work these with the time we have remaining. I'm sorry I didn't get to reviewing the reviewing the test just yet. Friday we will review for the final exam, part 1. And okay, so problem 55. This is easy. We just do what? We take the exponential of both sides, right? So e to the natural log of x is equal to e to the 10. E to the log x is just x. The answer is x equals e to the power 10.
Does E actually have a number, or is it
E is about 2.71.
Okay, so it's like
Yeah. Yeah, it's exactly. It is like pi. It is transcendental. You can prove that E is transcendental in calculus too. How? Using calculus. So, it's my non-answer to your question. All right, so it's actually somewhat involved. So this one, I would suggest we raise both sides to the 2 power. It's like exponentiate base 2. 2 to the log 2 equals 2 to the 2. Well, 2 to the 2 is 4, and 2 to this is just that. And then it's a quadratic equation, so we know what to do. We're supposed to know what to do. We will know what to do by next Monday, right? What is going on? So let's see here. What's the answer? X equals to 3, and x equals to minus 2. Now, we should probably check on whether or not those are actually going to give you, you know, an input to the logarithm which is negative. What happens if we put in 3 here? I get 9, minus 3 is 6, 6 minus 2 is 4. Okay. What happens if I put in minus 2? I get 4 minus a minus 2, which is 6. 6 minus 2 is 4. Okay, good. We're fine. So those are both solutions. Neither is extraneous. So, hooray.
So for 78, it's like the same thing. We do the 4, the 2,
Mm-hmm.
4, and then like 3 to whatever that number is.
Okay, so that gives us log base 3 of x equals to what? 16, right? 2 to the 4 is 16?
And then do the same thing, but with now 3.
Yep, now 3 to that is 3 to that, which gives me x equals 3 to the 16 power, which is a big number. So, you know, setting aside like word problems in chapter 4, you know, I probably could say more about like modeling with exponentials or something like that. And there's some problems about solving inequalities at the end of the section I haven't dealt with yet. And also, there are actually some problems in your textbook, like, for example, number 69. The problem is log x equals to 3 minus x. How would you solve that? how would we solve the natural log of x equals to 3 minus x? I'll put it up here. Natural log of x equals 3 minus x. So what I would do in this situation is something like, look at it graphically. Natural log of x is this thing. All right, this point right here is 1, 0. 3 minus x has a y-intercept of 3 and a slope of minus 1. So it's something like this. So is there a solution? Yes. Is there more than one solution? I don't think so. This is the solution right here, whatever that is. And so how would you find that solution? That's right. You need to get a calculator and actually like zoom in on it. If you got a graphing calculator, you could do that. But in the instructions, it says solve this numerically, because this is one that you can't isolate x, at least not with the class of functions that we work with. There is something called the Lambert W function, which I think might allow you to solve this, but anyway, with our usual lexicon of functions, we can't do it, except numerically. And you can kind of see that the answer should be somewhere between, what's this point here? That's like 3. So I'm guessing that the answer is somewhere between like 1.5 and it's probably about 2. 2 is not right, but it's kind of close to 2. Anyway, yep. So that's it. So I'll see you guys Friday to review for final exam part 1, all right?
Is there going to be a study guide for this test?
The whole class is the study guide.
I still don't know how that guy managed to break the math problem in one go.